future value annuity, and derivation of formula. Recall that regular investing and saving money for the future is an example of application of future annuity. Here, a fixed sum of money is invested at regular intervals. We calculate the future value of all these payments after a certain period of time as it accumulates interest, which is compounded. Let us understand this concept in more detail using an example and derive a formula for calculating the future value. Velma's daughter is studying in grade 11 and wishes to pursue engineering after matric. She decides to set up an investment wherein she deposits 7,500 Rand into an investment account at the end of each quarter for a period of 5 quarters to fund her daughter's education. The bank offers her an interest rate of 8% per annum, compounded quarterly. Determine how much money is available in the account at the end of 5 quarters. Recall the formula for compound interest. Note that in this formula, I is the effective interest rate. I nominal equals 8% per annum compounded quarterly. I equals I effective equals 8% over 4 equals 2% per quarter compounded quarterly. Let us make use of a timeline to summarize the data given. Here, T1 denotes the end of the first quarter, when she starts investing money into the account. She further invests 7,500 Rand at the end of the second quarter, that is T2, at the end of the third quarter, that is at T3, and so on until the end of the fifth quarter, that is at T5. Now, let us calculate the accumulated amount for each deposit that has been made into the account. Note that the compounding frequency in the interest rate matches the frequency of making deposits. Observe that the last deposit of 7,500 Rand will earn no interest as it is deposited at T5, that is the end of 5 quarters. On the other hand, the first deposit of 7,500 Rand will earn the maximum amount of interest as it stays in the account for 4 quarters. We will start with the last deposit and write down the future value for each deposit and set up the equation. Recall the formula for compound interest. We can see that Velma makes 5 deposits. The 5th deposit made at T5 earns interest for a period of 0 quarters. The 4th deposit earns interest for 1 quarter. The 3rd deposit earns interest for 2 quarters. The 2nd deposit earns interest for 3 quarters, and the 1st deposit earns interest for 4 quarters. We can set up this equation in the calculator and find A. However, this will become extremely tedious to solve if there were, say, 50 deposits made into the account. We can solve it in an easier manner by applying our knowledge of sequences and series and using it to derive a formula. Observe this equation carefully. This equation actually forms a geometric series where the first term, A equals 7,500, times 1 plus 0,02 to the power 0 equals 7,500, and common ratio R equals 1 plus 0,02 and N equals 5. Note here that in the equation R equals 1 plus 0,02, 0,02 is simply the effective interest rate I. In general, we can write R as R equals 1 plus I. Sum of a geometric series is given by Sn equals A times R to the power n minus 1 over R minus 1. Substituting the value of R in this equation, we can write Sn as. Here we can use X instead of A to denote the regular payments that are being made into the account. We can use F instead of Sn to denote the future value of the investment. Thus, we have derived the formula for future value annuity as F equals X times 1 plus I to the power n minus 1 over I. Substituting the value of X, I, and N in the given example, we find the future value of Velma's regular investment. F equals 39,030 Rand and 30 cents. Therefore, the amount of money that is available in Velma's investment account at the end of 5 quarters is 39,030 Rand and 30 cents.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.